The best 3D printer designs aren't the prettiest, they're the ones that work. As an engineer, here are 4 design tricks that immediately tell me someone knows what they're doing. The last one completely changed how I approach design. Take a look at this part from the laptop stand I designed. These pins need to hold the weight of my laptop, otherwise it'll smash straight to the floor. In order to do that, they need to be strong. The most logical way to make them strong is just to print the parts solid, but that would take an incredible amount of time and material. So the best solution is to just reinforce the area around the pins. I'm using an overlap modifier in Cura to achieve this, but I'll tell you right now, this is not the best solution. It's fine if you're just printing for yourself, but if you want to share or sell this model to other people, it makes it more complicated than it needs to be, and it could still be stronger. Where your infill meets your outer walls is actually a point of weakness. The secret to create really strong 3D printed parts is to use your walls to create loops, and it's easier than you think. Check out what happens when I make this cut through the entire part that's just big enough to touch both inside faces of the pins. Let's compare this to our original solution of increasing the infill. By cutting a hole through the entire part, you can see we've forced Cura to generate loops that run around through the pin. This attaches it right into the internal structure instead of just relying on infill to kind of glue it to the surface. As a result, the part has been super strong, but a smart use of walls is not the only component in great 3D design. If you've printed for a while, you probably run into elephant's foot, the issue where your first layer squishes out larger than designed. It can actually be a useful thing for improving bed adhesion, but it can also ruin your close tolerances. You can fiddle with various slicer settings to reduce it, but the most reliable option are chamfers. By undercutting the first layer just a little, you offset the effects of elephant foot and have a much more reliably fitting part. That is just one way that using more chamfer and fillet features can enhance your design. Fillets can also significantly make your parts stronger. You see that white line forming at the sharp corner? That's the plastic deforming over that line due to stress concentration. A large amount of the force I apply is being felt at that sharp angle. By using the same amount of material but adding a fillet, the force I'm applying is felt over a larger area, so the stress in the part is reduced. You can actually see the deformation spread over a larger area on the fillet than the sharp corner. As a bonus, the fillet makes the shape feel smooth, where a sharp corner accentuates the low quality of the plastic. 3D printing is often viewed as being a low quality method of production, but using chamfers everywhere can often improve the feel of your prints. I was initially surprised when I first found out fillets can actually decrease warping, but it makes a lot of sense when you really think about it. Warping is the result of long layer lines contracting. When these lines meet a sharp corner, there is very little surrounding material to hold the part to the bed. Compare that to a rounded corner and you can see there is no single unsupported point that the print can start peeling from. But what if I told you there was a way to almost completely eliminate warping altogether? I'm setting up a worst case warping test by forcing layer lines to run as long as possible with very little surrounding support. I'll also add those sharp points to give warping a nice weak place to start. The first part I'm going to leave as is, but the second we're going to completely eliminate warping. The idea is to add extra material to support the points most likely to warp. We're going to do this by adding little tabs. I was actually surprised by how well this worked. I thought I'd need to make the tabs much bigger to get the same result. It just goes to show that even a little extra bed adhesion in the right spot can make a huge difference. They're also really easy to remove. The only downside is they leave behind a small blob of material, so you might need to give it a quick sand afterwards. You can take this idea a step further by designing your own tabs to use in your slicer. All you need is a shape with a wide base and a thin connection point. Place it so it's just touching any area of your model that's likely to warp, then duplicate it anywhere else you need. You can also scale the tabs up or down in your slicer depending on how much extra support each part needs. Self-tapping screws almost always fail along the layer lines. If the screw is parallel to the layers, it acts like a wedge, forcing them apart and often splitting the print right down the middle. If you rotate the part 90 degrees and you solve the problem, it creates another one. Instead of splitting, the entire mounting point can snap off where it joins the rest of the model. I started thinking about this recently after designing a foot pedal for a sewing machine and having that exact scenario happen. One option is to print the part at an angle so the layers aren't aligned with either failure direction, but that's usually impractical because the geometry often requires a lot of support. But here is the better solution. Print layer lines in both directions at the same time. Here are the same layer lines forming rings around the screw boss, the same orientation that snapped earlier. And here's the other orientation, the one I used for the pins in my laptop stand. So if both of these orientations fail with self-tapping screws, why did the laptop stand work? The difference is support. In the laptop stand, the layer lines form continuous loops inside the pins, and once a pin is inserted into the base, it's tightly gripped by its corresponding hole. With the foot pedal, the screw boss is just stacked on top of the layers, leaving a weak point where it meets the rest of the part. That's when I realized I can just print myself a hole. So long as the layer lines are concentric, this will reinforce the part in the direction of the splitting. Normally, I would make the ring the same length as the screw boss for the best results, but you can clearly see how much of a difference just supporting the top makes. I will admit the fitment does need to be tight. If it's not, the results are significantly worse. There you have it, 4 3D design ideas that if used correctly can immediately elevate your designs above everyone else. Thanks for watching, please like and subscribe, and I'll see you in the next one.